All right, we're back. We're on page 2 of notes 15, and now what we're going to do is talk about these summation formulas that you should have seen at some point. If you didn't, that's okay, because we're going to do a couple problems right now to kind of like illustrate it. If you did and you don't remember them, that's also okay. You just have to remember them now. Let's go over them. So if we're going to sum up from 1 to n, just see a constant, then that's just like the constant plus the constant plus the constant, however many times you need that. So that's just going to be c times n. And that one's pretty straightforward. So the sum of a constant from 1 to n is just c times n. Okay. The next one is the sum of I from 1 to n. So you're summing up I from 1 to n. That's going to be n times n plus 1 divided by 2. There's kind of like a clever way to like represent that, sort of. I don't know where to draw it, but you basically draw like a staircase, right? So if we wanted to add up 1, 2, 3, right? I mean, it's obviously 6, but that's okay. What you do is you draw a staircase, and then you flip the staircase and put it on top of itself. And what it does is it always makes a rectangle, right? So this is now, we were adding up 3 terms. So it's like 1, 2, this part, what am I doing? This is 3. You know, I put it like too close to some, here we go. Okay, so this is 3. And then when we flip it and put it on top of itself, we create a 3 plus 1, right? And if it had been 4, it would have been 4 plus 1. If it had been 5, it would have been 5 plus 1. So we go 3, 3 plus 1. So the total area here is 3 times 3 plus 1. But we only want half of that because we want the original, so divided by 2. That's where the idea of n plus 1 divided by 2 kind of comes from. So that's like really useful, and we're going to use it a lot. I squared. I have a bizarre way of remembering I squared. So it's n plus 1, 2n plus 1 over 6. So the way that I remember it is when you just, so first you got to remember this one, n times n plus 1 over 2. So n plus 1 over 2. And then what you do, I don't know, this is not like the, well, I don't know, it's how I remember it. You multiply the top by the most generic odd number that you can, and the bottom by the next odd number, right? So the next generic odd number is 2n plus 1. And then since this is 2, the next odd number is 3. And then if you simplify this, you get n plus 1, 2n plus 1 over 6. That's how I have always remembered that. I don't know that I don't think there's anything mathematical about that other than like, oh, I found kind of almost a pattern that sort of helps me. I don't think there's like a thing for it. And then I cubed, insanely, if you can remember this, then the sum of I cubed is actually just the square of this, right? So instead of n plus 1 over 2, you have n squared, n plus 1 squared over 2 squared. So like, it's not as hard to remember as maybe it should be. So those are our formulas. We have to remember them. And let's see if we can use them. So here we go. All right, I'm gonna do, I don't want to commit to anything yet. I'm definitely breaking this into 2 videos, but we'll see where that happens. All right, step 1, expand. I don't know where to do that. 5, what am I doing? Okay, I couldn't remember how to make a 5. I was trying to make a 5 and a sigma at the same time. So 9, multiply them together times 2, so 12i, and then square it, 4i squared. Remember, it's not the complex number I, or the imaginary number, it's just I, it's a counter. Sometimes you'll see k used. You could use n, you could basically use anything really. I like to use I. So we have this. All right, now I'm gonna break this up into 3 summations because you're allowed to do that. So this will be the sum of 9, and then I'm going to say minus 12 times the sum of I, and then plus 4 times I squared. Okay, so that actually, those properties are really similar to the properties of integrals. I find most of my students know the properties of integrals better than they know the properties of summations. So like when in doubt, like if you can do it with an integral, you can probably do it with a summation. So like constant multiple rule applies. You can add and subtract them. It's like That's a pretty not terrible way to do it. All right, so now what are we doing? We're gonna do, for the first part here, it's the sum from 1 to 5 of 9. So a constant, that's just the constant times the upper bound. So this is all, it all presupposes that you're starting at 1. If you're starting at 1, then you can do these things. If you're not starting at 1, then it's like almost like all bets are off. Not really, but like kind of. All right, so the sum of I from 1 to 5 is n. So n is 5. We're going to do n plus 1 divided by 2. So this is going to be, I'll put it in parentheses, 5 times 6 over 2. Okay, so that becomes this. Double tapped becomes this. I don't even know if it bothers anyone else. I just hate that. Okay, so now we're going to do I squared from 1 to 5. So we just have to remember the formula. It's n plus 1, 2n plus 1, and then divided by 6. Okay, and so this is this. So we're just using the formulas, going through, really not that bad. And now we have to simplify this. So like, I don't, do we want to, I guess we should simplify it. So I don't know if I'll make you watch all of that. What do we got here? Minus 6 times 6 is 36 times 5 is 180. And then the 6's cancel. 55 times 4 is 220, I think. And then negative 180 and 220 is 40, and 45 is 85. I think we get 85 there. I will check it on the calculator at the end, but I think that's probably right. So one of the keys is you just have to expand, because we only really know these formulas. We don't have like others at our disposal. So if you get something weird, you have to expand it and hope that it works out to something you recognize. So we're going to go from 8. It's really hard to make an 8 on top of these, because eventually in your life, you're going to put infinity up there all the time. Whew, hard. All right, 4i squared minus 4i plus 1. Keep cleaning, like clean it up until you can break it into each individual thing. So I'm going to say this is 1. I tend to go in like reverse order so I can use the formulas in like order of complexity, I guess. Minus 3i plus 4i squared. How much space do I have? Kind of a lot, although I don't really know why I have a lot, so I don't know if I want to use it all. 8, I equals 1 of 1 minus 3, 8 of I plus 4, 1 to 8 of I squared. All right, now we use our formulas. So this is just a constant from 1 to 8. So it's 8 times the constant. So just 8. I'll write 8 times 1. And I guess this is from this, just to keep track. And then minus 3. The sum of I is going to be n plus 1 over 2. So that's this. And then plus 4. All right, so it's going to be n plus 1, 2n plus 1 over 6. And I don't want to simplify this. I'll check this on a calculator. I don't want to spend all day doing arithmetic, as you all know. Or, well, if you watch a lot of these videos, you know, I kind of, arithmetic's not my, like, it's not my thing. All right, we got to cube something. How many problems are there? These both look like they're going to be like some work. So let's just do this one. So 6. I mean, it's going to be like 1, 3, 3, 1. We could like break it up. I don't know. Probably not. 1, 3, 3, 1. Right. So it's like this thing cubed, and then to the first, second, for 1, 3, 3, 3, 2, 1, 0. And then this is to the 0, 1, 2, 3. And then the coefficients are 1, 3, 3, 1. That's how I expanded that. You can multiply it out. You can remember it. Like, all kinds of options. All right. So, all right, I'm gonna like skip one step here because I think it's a normal thing to do. Usually I don't break it down as far as I have been, like to this. So I'm gonna go straight from this to like almost the last step, but I'll still highlight to like show you where things are coming from. So first it's the sum of 1 from 1 to 6. So that's 6 times 1. And I'll highlight at the end. And then it's plus 3, the sum of I from 1 to 6. So that's going to be 6, 7 over 2 plus 3, the sum of I squared from 1 to 6. So that looks almost identical. It's 6, 7, and then it's going to be 2n plus 1, so 13 over 6. And then it's going to be the sum of just I cubed. So I cubed is like, it's like n times n plus 1 over 2, but you square it. So it's n squared, n plus 1 squared over 4. Okay, so I'm going to highlight this, and then I'm going to grab a calculator and just like do it on the calculator. So this came from here. This came from this part. This came from this part. And then I need another color. This came from this part. All right, so I'm gonna use a calculator to check. The easiest way to check on the calculator will just do the sums. Like you don't really need to do anything, but then you have to like check and see if your whatever works out the same. So calculator, first let's do the sum the way that it's given, right? So I 1 to 5, quantity 3 minus 2i squared, 85, that's what we got, so that's definitely right. Let's try the next one. So I did not simplify this one because I thought that would save us possibly a lot of time. 2i minus 1 squared. All right, so 716 is what it gets. So I got 8 times 1 minus 3 times 8 times 9 over 2 plus 4 times 8 times 9 times 17 over 6. 716, so we got it right. And then the last one was from 1 to 6 of quantity 1 plus I cubed. All right, so we should get 783. We got 6 times 1 plus 3 times 6 times 7 over 2 plus 3 times 6 times 7 times 13 over 6 plus 6 squared times 7 squared over 4. 783. Okay, so we did them right. I'm gonna go back to the notes so you can like take one last look at it, I guess. And then I'm gonna break this video into 2 so that we don't have to, the next ones are a little tiny, they're very small amount different, but they're a little bit different. So this is what we did so far. We'll be back in the next one to do a little bit more. So I will see you there.